Hey, yo, what's up? It's Pure LabZ, and welcome back to another video. I know I've been a long time I haven't posted, but now I'm back with a very interesting project. So today I would like to represent you a DIY vibratory bow feeder project. This is our final project for a course at RMIT called Design for Assembly and Manufacturing. This is not a solo project, it's a group one. But today I'm going to represent my friend and my team to show you guys the overview. How did we make this? Alright, so if you know what is a vibratory bow feeder, I'm gonna skip that. You can totally check the concept. But I will be summing up a very simple concept. So basically it's going to utilize the vertical vibration plus the inclined angle from the spring creation to move the things in the bow move forward. Yeah. Why do we have to use this machine? Very simple. We want to sort stuff. So let's say I got some bow and nut in this small bowl right here, and I want to short them. I want bow to go to the bow container and also the nut the same. So that's why we do it. All right, now let's have a closer look on our build. So most of the project, the mechanical build, are using 3D printing manufacturing because it is easy to prototype, to test, as well as the price is very affordable. So currently, we mostly print in POA, but you can also do it in Petri because the surface of Petri is very good for this project. But POA is fine. All right, so let's go with the base. I'm gonna assume that you guys already know what are the basic component of a bow feeder. Okay. Oh yeah, by the way, our project, we are using a magnet vibration. Yeah, we're utilizing by the magnet, so it's going to continuously pulling and pushing the armature right here, yeah, to create a vertical vibration like this. Yeah, and in the code we are going to program it to run like a sine wave signal like this. If you know what is a sine wave, of course everybody know what is that. Okay, so let's go to the design from the bottom to up. The first thing, very important, is called a base. This is our base design. We are using a 4-spring pack for this project. And as you can see inside, I hollow it. So I could easily assembly by the bolts right here, okay? As well as you can put any ballistic materials like sand, rock, cement to make your base very firm. Yeah, because it really needs to be heavy to work appropriately. But sometimes, like in this project, we don't need it to be so robust because we got a trick. All right, coming up is the 4 set of spring. This is a spring, guys. It's gonna be something that bendable but not too bendable. Okay, it's going to help the pieces in the bow to move forward, because you can see it got an inclined angle right here. So we are using 4 type 1. You can use a 3 set of spring design, that also gonna work. But if you use a 4, it's going to be more effective, gonna be more faster. But in reverse, you're going to need a very stronger force as well as bigger electrical consumption. Yeah. Alright, and then we put a magnet in the middle, as you can see right here. Coming up, let's move up. I call it the spring attachment. Yeah, the upper spring attachment, because one side of the spring is going to be connected to the base and the other end is going to be for the spring attachment. I call it upper spring attachment. Let's see anything about this. So this spring attachment is mainly to connect the springs and to put the armature. So the armature is a metal thing. It's going to be pulled, right? To be pulled by the magnets continuously. So in this case, we're using very thin circular strike plate, and then we stack them up to create some visible thickness, yep, to ensure a better performance. All right, and the last thing here, the mechanical thing, is going to be the bow. Yeah, of course, it looks like a bow, so that's why it's called a bow feeder. Okay, the bow is going to be circular shape. So usually the piece gonna go circular like this, yep, from the bottom to the top, and then it's gonna reach, at some point, it's gonna reach the shorting mechanism section that you designed for your piece, okay? It really depends on what you want to short, and then your design is going to be formed from that requirement. Okay, so I'm going to talk a little bit about our shorting mechanism because it's also important. Like I told you, we're going to short M3 nut in the bolt. So we have a space right here. So the very first small space is going to be for the nut. So when the nut moves to here, there's going to be an inclined path, and then plus with the vibration, the nut will definitely fall down. For the bolt, it's going to be longer, heavier. It's going to be stuck in this edge, yeah, and then it's gonna move along this side until it's reached to a bigger space and then fall out. Basically, there is a space between them, so we can later design a track, you know, to guide the shorted pieces into the container. Because we're just focusing on the mechanism right now, so the post-processing is not important. Okay, anything else on the bow? All right, you can see here, we got this little green cone-shaped thing. We make it because we see that our bow, when it's running, every pieces in the middle of the bow is not going to be moved as expected. So that's why we come up with a solution is to put something like a cone shape in the middle, so whenever we put the pieces inside the bow, they're going to fall scatterly onto this track. Okay, yeah, because we can see that if they're on the track, they tend to move better. They respond to the microflow principle obviously. So that's why we designed this cone, and this cone also help us to save some time when you want to short, because they already on the track. They don't have to move from the bottom and then move gradually to the track. Yeah, you see what I mean? Okay, that is about the mechanical build. On the electrical one, we're gonna use three main things. The first thing is a microcontroller. You can use any kind. An all-free or a nano is already enough. And the next one is a motor driver. You can pick the good one, the one with the bigger current handling. So the magnet, because you know, according to our calculation, it's very important that the higher current that you are able to enable from your specification, the better your project will perform. Yeah. And then the last one is a power supply. We're using a 12 volt 30 amp power supply. Yeah, that's it. Pretty simple. And for the code, you can honestly ChatGPT stuff. It's really good at this. Yeah, our code was suggested by GPT, and I think that it did really good in suggesting. So that's why you guys should try it out. Okay, now I'm going to do a little demo for you guys so you can understand better the project. All right, so I'm going to pull these pieces into the bow, and please pay attention to the things gonna fall out from here. Okay, I'm going to put it like this. Okay, and now I'm going to put them inside. You can see they're going to fall. Okay, now I'm gonna plug the cable in to the Arduino. All right, so you can see that it's not moving, right? Because our spring there are from 3D printing, so that's why they're bendable. So for now, I have to use my hand to make the spring work. Okay, see, you can see everything is moving. Yep. Wow. Oh wow, some of the nut has come out from the bow. Yeah, as you can see, it's really cool. I'm going to give you guys another testing video that we had on a demo day so you can have a better look. Come on. Okay, they are stuck for a little bit. Usually this should be like a two-man operation. See, all right, another one. I'm going to use my hand to push here. I think it's been a couple of weeks that I haven't touched this, like 1 week, so that's why they're stuck. It needs maintenance, you know. All right. Okay, so that is the performance. Okay, so I'm going to put the video right here. Great job, guys. So thank you for watching. If you guys like this video, don't forget to leave a like and subscribe. I appreciate that.